Last example, you have a 25 kilogram child standing on a 20-degree incline and is held there by a parent.
Where does it say 20 kilograms?
25 kilograms.
Where does
What's your guys' example?
We
I
have,
was on a 20-degree incline and barely keeps himself still.
yeah.
Well, he doesn't have mass. Well, once in a while, what is the child's
20 kilograms.
Oh my God, it's recording.
mass? That's odd. My notes are different than your guys' notes.
Yeah.
Well, we'll go with this one. Assume that the weight of the child is 25 kilograms.
What do we?
Will the child slip?
9 on this. Do we have this?
Yeah, that's.
Yeah, you should. It's the
We
slanted
just do
friction.
ours.
The slanted friction notes. Just change it to it's a 25. Put 25 kilograms up there. And what it wants to know is, will the child slip? If the parent lets go.
Wait, did you get this? Give this on Friday?
Yeah.
That was one of it.
Were you not here on Friday? You guys taking bets on the election?
Oh, Jess.
It's a toss-up. It'll be a minority, that's for sure.
Not necessarily. It's most likely.
I think it's pretty dead even.
Yeah.
The last, like, I look at this, like, 3-4-2 or whatever, polling place.
Yeah, I don't like CBC polls. I like that one too.
Yeah, and it has,
342 polls or whatever.
yeah,
I wish the new
25. So the kid is 25 kilograms. Will the child slip at the parent? Let's go. Do you guys still have, like, the 20-degree incline?
Yep.
Yeah.
And you have the coefficient of friction at 0.55?
Yep.
All right, so.
Except for it does say that they are keeping themselves from sitting down, not the parents holding on. So
Same idea. I don't know why it's
I don't know about that. I gotta change the
So you got a parent holding the kid now, all right?
Well, that's two separate forces.
No.
Yeah.
Well, the parent's gonna let the kid go and stand there freely, and we'll see if they slip on this incline.
Why would you risk your child's life?
For science, silly. All right, so we have this incline now. Wait, what force was this way?
I'm not understanding your triangle. Where's the kid? He's the box.
Yeah.
It's supposed to be 25.
Oh, sorry, it's 20. $25 kg.
And that serves as a What is that?
This here? US. That's your coefficient of static
It
friction.
says coefficient.
Yeah.
But it'll shoot directly down at weight of 25 times 9.81.
Yeah. Remember you have your W1 and your W2?
No.
That doesn't remember.
Wait. W. Oh, yeah.
The bottom arrow goes down.
Yeah, it should be going down. Sorry. Mondays, am I right, guys?
Yeah.
Oh my god. gosh, I woke up this morning, it was the worst.
Okay, so that's what it'll look like.
Which one's weight one?
This one here, one straight down. So remember now, we can calculate weight one. That's just your normal weight, so that's just going to be mass.
Now weight two is what the weight that's.
That's your x component of the weight. And remember this here, it's also 20 degrees. Right? So we can always calculate these different weights here. So weight one, that's just going to be 25 times 9.81. Maybe like what, 240? 245. So now that you have this component, remember, of your triangle, the two formulas from the other day that I showed you guys them, you're not going to be given them on the test. But if you have your first weight here, you can use sine and cosine to find the other ones.
What's the MS?
US. That's the coefficient of friction, static friction.
He wasn't here that part.
He would have been here for the first stuff.
Well, why did you do an M then?
Oh,
Instead of the U?
yeah.
Oh, same thing.
Very allowed to do that then.
Well, it's just mu. I just made this one look goofy, that's all. It's the same symbol. Mine's just terrible.
Oh.
It's just terrible penmanship.
Oh.
Thanks, now I'm going to have complex. Okay, so now we'll find Fn. Fn is just the adjacent side, so we use cosine. So there's my normal force, and I can find my weight 2, or my x component of my force, or sorry, of my weight. And that's just going to be W1 cos, or sorry, not cosine, sine. Hopefully some of this is starting to come back from Friday.
When you get to 12.4, I go 230. Like 245.3, that's cosine 3.
Well, that's because I use cosine 30. Yeah, 230.
You can't use
You would need more than one side. You only have this side here.
found FM too though.
Now that you have N, you could use Pythagoras, yeah. But honestly, this is a little bit quicker.
How is what does FM equal?
Your normal force.
What would that be, the hypotenuse?
No. Your hypotenuse is your weight. Okay, so that 83.9 newtons, that's applied here. That's what your W2 acts upon, right? The horizontal aspect of the surface. So you have a force of 83.9 newtons pushing down as the kid's standing there. Well, we need to see if the force of friction, what that's doing. Because if the force of friction is greater than the force that the kid's applying, what's going to happen? If this force pushing on the child upwards,
The child's just gonna stay there.
bingo. All right, so we need to compare that. So now all we do is we do force of friction. Remember, that's just US times your normal force. Yeah, Brooklyn?
Oh,
Oh, no, I thought so. You were just yawning? Gotcha. So, well, our normal force we found to be 245.43. We know our kinetic friction. Oh no, sorry, our normal force is 230. Our force of friction was 127. Not moving. Now, do you guys see what can happen here if you were to increase the incline, let's say? I'm not gonna do the math here, but yeah, the kid's not gonna move, right? We can all agree on that. The force of friction is greater than the weight.
Wait.
Yeah, because the friction moves perpendicular, so you need this one here.
What's the point of weight one? Oh, yeah.
Yeah, well, weight one is just the first weight. Yeah,
Yeah, that's for everything.
yeah, you need that for everything else.
Except for force of friction.
Yeah. Now, if we were to increase, I'm just going to draw it over here. Let's say we increase this to now.
What if they're unequal?
If they're equal, they still don't move. It has to be a little bit more. If we were to increase this to, let's say, 40 degrees, 45 degrees. No. I'm just going to show you guys what would happen. The free body diagram. Little tykes there, 25 kilograms. You have a weight here. Okay. Don't say that.
No unit circles.
Now, when we increase this angle here, we also increase this angle here, right? The bigger we make that angle, what happens to our W2?
Sounds bigger.
It's going to get bigger as well. So suddenly your weight starts to increase and increase and increase.
Is there a certain angle that it is where it's always equal?
There will be one, yeah. Yeah, there will be one, but it depends on the amounts. Now, as W2 gets bigger, eventually it's going to get bigger than the force of friction.
Wouldn't the force of friction get bigger too? Or no?
No.
Never mind.
Well, actually what happens is as W2 gets bigger, the force of friction will get smaller. Because this will get bigger, this will get smaller. And remember, you use the Fn to calculate your force of friction. So eventually you're going to hit a point where this gets too small. Your force of friction is too small and you will fall. That's what happens when you're going up an incline. And because this one gets bigger and this one gets smaller at the same time, it happens at a much quicker rate than expected. Okay, any questions about this stuff, guys? How are we feeling about it so far?
I like it. It's pretty good.
Yeah? All right. The general vibe is...
I wouldn't say it's pretty good, but like, I don't know.
Well, that's good.
There's like
pretty good.
Really?
It was a great kinematics dynamics debate.